On planet Earth, we are facing critical environmental problems like the depletion of fossil fuels and climate change. In response, fuel-efficient, advanced, eco-friendly vehicles, cleaner, greener cars are now in high demand. Over several generations, our cars have grown larger and heavier to accommodate roomier interiors and better safety features, along with many luxury and convenience amenities. In order to improve the fuel efficiency of the automobile, we must first make them lighter. To make this possible, size and weight reduction for each auto part becomes essential. The purpose of size and weight reduction of auto parts reaches far beyond simply shedding the weight. Materials must maintain their hardness and rigidity, that is, the strength to withstand bending and twisting, even as they are downsized. There are 4 basic techniques for size and weight reduction: material substitution, system miniaturization, consolidation of components, and redesigning of manufacturing processes. An example of material substitution is the replacing of conventional steel with high-tensile steel, making available thinner and lighter sheet metals. Others include choosing lighter metals like aluminum alloys and titanium over heavy iron, and using resins and carbon fiber where heat is not an issue. High-tensile steel is a product of nanotechnology and is much stronger than conventional steel. However, its strength also poses challenges in production, requiring advanced manufacturing techniques for stamping and welding. Today, high-tensile steel is used extensively in various auto parts. System miniaturization is achieved by optimizing the configuration of electronic systems, such as air conditioners and other electronic controls. Design improvements play an important role in making parts smaller and lighter. A part that is comprised of multiple components can be redesigned and consolidated into a single unit. By simplifying the construction, parts can be built with fewer pieces, making them smaller and lighter. Manufacturing processes are redesigned to adopt new techniques for making lighter and stronger products that require fewer parts. Availability of new materials can also open up possibilities for improved manufacturing processes. Now we'll explore how auto parts are made smaller and lighter. Let's begin with the engine. The engine houses a myriad of components, making it a particularly heavy part. By using lighter metals, such as aluminum alloys, it is possible to eliminate the excess weight. In addition, lighter pistons and piston rings result in smaller connecting rods. When oscillating parts are made lighter, they are also able to perform more smoothly. In the engine, even a few grams saved from a piston ring will help improve fuel efficiency. In the intake manifold that delivers air to the engine, heat-resistant resins replace the older aluminum construction, shedding significant amounts of weight. Surrounding the engine is the radiator, which cools the engine, and the air conditioning condenser. By improving insulation, these parts can be made slimmer and smaller as well. The transmission and the torque converter send the power from the engine to the drive wheels. Their size and weight have decreased steadily over time. The CVT is a combined system of belts and pulleys that delivers better fuel efficiency. This device is also becoming more compact. In parts that transmit power like the drive shaft and the propeller shaft, the center is hollowed out to eliminate excess weight. Connecting the shaft is the constant velocity joint, also a product of miniaturization. In the suspension, high-tensile steel and new forming techniques for aluminum alloys have helped create a lighter and stronger product. To reduce the weight of coil springs in the suspension, the components are made narrower, stronger, and with fewer coils. In earlier efforts, leaf springs that are often seen in vans were constructed with lighter, fiber-reinforced plastic. The hub that connects the drive shaft to the wheels has been improved through weight trimming design modifications that maintains its material strength. For wheels, lighter steel versions are being produced alongside lightweight aluminum wheels. Thinner designs optimized for high-tensile steel are also currently in development. Advanced technologies in molding and welding have made it possible to use a particularly strong type of high-tensile steel. In tires, efforts to minimize rolling resistance are underway. Fuel efficiency is improved by reducing friction. With improvements in the cast iron for the brake rotors and the use of lightweight aluminum calipers, brakes are also smaller and lighter. Efficiently designed brake boosters also help minimize its size and weight. Electromechanical brake uses a motor to apply braking pressure, eliminating the need for brake boosters and hydraulic lines. With a simplified construction, the braking system as a whole becomes more compact and lightweight. With increasing number of electric amenities such as climate control and navigation systems, it's necessary to reduce the weight of wiring harnesses that connect these components. Wiring harnesses are made lighter by using finer cables. In addition, printed circuit boards integrate multiple components into a single, tighter unit. Headlamps and other electronic parts are miniaturized and consolidated for weight reduction, and LEDs have become more prevalent due to their efficiency and longevity. Motors and other electronic components have also shed much of their bulk and weight through creative design modifications, including the window regulators that move the glass up and down. In places where the frame requires extra strength, aluminum alloys and high-tensile steel are used selectively, and prior to stamping, sheet metals of varying material and thickness are welded together to provide reinforcement. Strategic selection of materials and thickness help achieve strength, rigidity, and lightness. In addition, parts are heat-treated at the time of pressing to enhance material strength at thinner dimensions. New welding techniques also help reduce the number of pieces required to build a part. These improvements all contribute to producing a lighter frame. In other areas, the sway bar, a part responsible for stabilizing the body, is hollowed out to remove excess weight. Design improvements in the crash box, a safety feature that absorbs the shock during a collision, have also resulted in significant weight reduction. The bumper and other body parts are made with lightweight materials like aluminum alloys and urethanes. Constructing sunroofs and back doors with resins also lower the weight substantially. In the interior, urethane foam ceilings and door trims made of carbon FRP and expanded polypropylene are examples of how new materials and design can recreate the strength and the quality of the original materials. Design modifications in the seat frame have increased comfort for passengers while reducing the number of parts in its construction. As you can see, by reducing the size and weight of many individual parts, we gain not only in fuel efficiency, but also in overall driving performance like handling and braking.